We're going to create some averages functions to compute the mean, median and mode of a list. So we've got some skeleton functions for those, and also some test code to check how they work. Let's start with the mean. So we need to calculate the sum of all the elements in the array, and then we need to divide them by the number of elements in the array. So we'll start by defining a sum, and initializing it to 0. Then we can run through all the elements in the array, and we can add that to the sum. And we need to dereference EL because it's a reference to an I32, not an I32. Then we can return sum divided by the length of the array as a floating point number so that we can carry out the division. Let's test that. We'll run the project with cargo run. And we get some warnings because the other functions aren't finished yet, but we can see that the mean is being computed here. Next, let's calculate the median. So we have two cases here. The first is when the length of the array is even. Then we have two elements that are near the middle but no real middle. So we'll compute the arithmetic mean of those two middle elements. We can get the lower element by doing... So this is taking the length of the array and doing integer division, which will truncate, which helpfully ends up lining up with the index that we want into the array. Then we can get the upper element by doing array length divided by 2 plus 1, and we can divide those by 2 to compute the average. And this time we want to do floating point division. Otherwise, we can retrieve the middle of the array when the array length is odd. Which is simpler. There we go. Let's test that. So we'll run it with cargo run. And it's complaining that the element we selected from our array is assigned integer, but we were looking for a floating point. So we need to have cast that. Let's go back and make that change. So we'll just quickly cast the element we've looked up from our array to an F64. And that should solve the problem. Let's try the cargo run again. And this time it sensibly computes the median as the middle value of an odd length list. The last average function is the mode, and this is probably the most interesting. So to compute the mode, we want to find the most commonly occurring element in the list. To do that, we're going to keep track of the count of each element in the list with a mutable hash map. Then we'll run through the list and find the counts for each element. So if the element's already in the list, contains key element, then we need to increment the value associated with that key. We'll do that by inserting at element the value counts at the element plus 1. So we take the value that's already in there, add 1 to it, and store it under the same key. Otherwise, we'll just insert into the map, because this is the first time we've seen it. So that gives us the counts keyed by each element. Now we want to find the element that has the highest count. So we'll do a loop through the map. And we need some way to keep track of what we're finding. So let's declare some mutable variables. We'll initialize a mode variable to be a minimum value, and we'll declare the max count that we've seen to be 0, because the smallest count we can see is 1 for an element. So if the count is greater than the max count, then the mode becomes the new key, and the max count gets updated to the current value. then we can return the mode. Let's check if that works. So again, we cargo run the project, and it computes the mode as 4, which is the element that appears 3 times. So it looks like that's working. The mode function could be improved slightly. So the first problem is that if we find a max count, we never update it if there's a second max count that will be the same value. So it's possible for an array to have multiple modes, but we only find one. We're also storing a hash map with the counts for each element in the array, which is fine for short lists or lists that have a lot of duplicates. But if we have a large array with lots of different values, then we're storing quite a bit of extra memory here. Can you find a way to compute this that doesn't use extra storage? It just keeps track of the values we've seen so far in the array. Thanks for watching, and good luck.